Alright, hello. We will be presenting how to use the ChemEd data. In this case will be for inorganic molecules. There is another video showing how the organic section works, but in the present video we will comment a little bit how to better use the ChemEd data in the case of inorganic or chemical elements. Actually, that's the first thing that we see when we load the website and under the inorganic button. The first thing that we see is the Elements tab has been selected, and what we can see here is the boiling point of the elements in their standard state. Of course, these are gases, so they will have a much lower boiling point, but typically in undergraduate and even high school chemistry courses, you may see how the atomic radius changes, and we can use this periodic table on the right to select what elements we want to show. We can select the second, third, and fourth period and see how the atomic radius changes in different periods. Other typical property is ionization energy. Why is it that noble gases have the highest ionization energy? We could also narrow down a little bit the selection, so of course we can keep selecting or unselecting some of the properties, and as we select them, the graph on the left is being dynamically updated. We could also select it here, say that I'm interested only in showing these specific elements, and I click plot selected. The table and the periodic table gets dynamically updated at the same time. We may also want to look at, so for example, say that we are very interested in this specific selection and we don't want to go through the problem of selecting each and every one of these. So we may want to just save this selection. So this means that this URL with this specific stamp is now associated to this selection. So every time we load this URL, we will come up with the same selection to be used for in future instances, or even to submit it to a professor if you want to make an assignment, etc. Also, for a specific selection, you may also want to view the crystal structures of these specific elements that you selected. So I click View 3D, and what this does is it connects to the Models 360 database hosted in the chemeddl.org that I developed some time ago. And so these are all pretty much just remote pages of the crystal structure of those elements. So the ones that we just had selected in this other tab. Okay, so these were for the elements of the periodic table. Very similar functionality is available for also inorganic compounds. Inorganic compounds, now we're just going to select, say, the second row, and here's showing a lot of compounds, oxides, for example. I'm sure that if we see the moment there is no compound selected, of course the table is empty. We could select halides and say instead of 100, I'm interested in only 10, and I'm interested in just showing the one with the lowest boiling point. Makes sense that the covalent compounds are the ones with the lowest boiling point, so I can just select them, plot selected, and here you have an increasing boiling point, these different compounds that contain at least one halide. Again, you can do the same and view the 3D. In this case, it's not the crystal structure. What will happen is if you click here, there are some inchy keys in the URL that are dynamically taken. It may take a while to load because all these structures are downloaded from an external database. So some of these structures, such as silicon tetrafluoride, the more ionic the structure is, the more incorrect the structure may be. But if you select covalent molecules, most likely you may have a pretty accurate description of the molecule. JMOL, or the JavaScript version, JSMOL, can calculate on the fly partial charges of specific molecules, and therefore can calculate molecular dipoles, can also calculate molecular electrostatic maps. You can just turn it off and you can do the same for all of them. Okay, even exploring different elements of symmetry, which may explain why is it that, for example, the one dipoles point to this way, but the molecular dipole points this way. If you really want to operate them all at the same time, click on Synchronize Mouse, and then you can see how rotating one molecule makes rotate the other ones. Okay, so this would be, in general terms, the basic functionality of the inorganic section of ChemEd data. Thank you for your attention.